Actor-Critic is an interesting variation on policy gradients. Instead of using vanilla TD1, we're going to bring back our BFF, the Q function, so we can implement a popular version of the algorithm called Advantage Actor-Critic. There's an even fancier version of the algorithm called Asynchronous Advantage Actor-Critic, or A3C, which involves many workers simulating in parallel, but it turns out the simpler A2C works just as well in practice. Here's the premise. The Q function can be broken down into two functions. One is the value function that we already know and love from TD lambda. It estimates a value based on the state. The advantage function, big A, is how much value of a state changes given an action, or little a. This is the new architecture of our model. There are now three sets of output nodes. The first, predict, which is the same as our predict for policy gradients. It's going to tell us with what probability we should choose an action. Next, the actor. It's the same as our policy network from policy gradient and trains in the exact same way. Finally, the critic. It's going to try and represent the V in our Q-learning function, whereas the actor will learn based off the advantages. It does look like a lot here, but keep in mind, we've already done this part so far. We just need to figure out how to add in this part. This time, our network is going to return 3 networks instead of 2, but there's only 5 lines we need to change. First up, we need to add an output node to predict the value of the fed-in state. The actor network is the same as our policy network from before, and is what we're going to train on. It has 2 loss functions, our custom function for the probabilities like before, and mean squared error for the value estimate. By default, Keras will weigh them evenly. The last new line is the critic model. It takes in state as an input and outputs its estimated value. Our learning function combines both our Q function learning and our policy gradient learning. When we train, we'll collect information on when the episode ends, or DUNS MB, and the critic's prediction on state prime, or next VMB. And then we can use the Bellman equation like we did before. Similarly to how we predict the value of S prime in Q-learning, we're going to predict the value of our states using the critic network. That way, we can subtract it from the discounted rewards calculated by TD0 to find the advantage. Finally, we train the actor model with the states and advantage, fitting to the chosen action. And for the critic, we train on the states, fitting to the discounted rewards. And that's that! We've officially converted policy gradients to A2C. We went through a lot of code very quickly, so if you'd like to go through each algorithm line by line, I recommend checking out Phil Tabor. He's a YouTuber who does this gutsy thing where he codes these algorithms live and explains what he's doing. That concludes the end of our algorithmic journey. I hope you've learned a little bit about yourself along the way. Were you able to pinpoint what type of learner you are? Reinforcement learning is still a rapidly growing field, so if you're able to quantify your understanding of yourself, who knows? You might have a breakthrough.